Hello, good morning. This is part 3 ng additional topics sa differential equations of order 1. And for this video, we are going to talk about Bernoulli's equations. So pag sinabi nating Bernoulli's equation, ito yung mga differential equations that take the form as such. Yung nakikita natin. So y prime plus p of x or function of x, y equals q of x, y raised to n. So kung natatandaan nyo yung ating first order linear differential equation na topic, kamukhang-kamukha niya actually. Ang Bernoulli's equation ay mukhang first order linear differential equation. Yun nga lang, kailangan mo tanggalin itong banda dito. So kapag tinanggal natin yung y raised to n, kapag wala iyon, magiging first order linear differential equation siya. So I hope you still recall or remember paano mag-solve ng ganito. So pero kapag meron siyang y raised to n na nakamultiply dun sa qfx, ang tawag natin doon is Bernoulli's equation. So let's analyze. For values of n, for example, if n equals 1, ibig sabihin magiging 1 yung y raised to n natin doon. Magkakaroon tayo ng y prime plus p of x y equals q of x y, which is basically kapag transpose natin yung p of x dito sa kabila, we can factor out y, and since y prime is dy all over dx, cross multiplication and a little algebraic manipulation dyan, we will end up with variable separable. So when n equals 1, variable separable yung ating equation. And of course, when n equals 0, that means y raised to n equals y raised to 0, or that is equal to 1. So matatanggal iyon, and that will become what? A first order linear differential equation, which is na-solve na natin yung methods in finding the solution. So we will focus on um, Bernoulli's equation na kung saan yung power or exponent ni y or yung n natin is not equal to 1 and also not equal to 0. Pero pwede din siya sa not equal to 0. Specifically, wag lang tayo, hindi lang natin siya isa-solve for y or for n not equal to 1. Yan lang muna yung tandaan natin. So if n equals or n is not equal to 1, ano yung magiging method of solution natin dito? First and foremost, pwede natin yung i-rewrite as yung y prime, palitan natin ng dy over dx, and then cross multiply natin, we can end up with this equation. So yung p of x, tinanggal ko na yung notation na of x. Just keep in mind that p and q here are functions of x. And then n is an exponent, so that is a constant uh, term or a number not equal to 1. Okay, tandaan natin, not equal to 1 ito. And how do we proceed? Kapag nire-write natin siya as this equation, dy plus py dx equals qy raised to n dx, we can divide uh, by y raised to n, lahat ng equation, para lang may matirang q dx doon sa right side. And if we do so, magkakaroon tayo ng y raised to negative n, kasi if we divide by y raised to n, yan, if we divide by y raised to n, makakancel siya dito. However, dun sa left side, magkakaroon siya nila ng y raised to n, pero nasa ibaba nga lang. So, kapag itinaas natin yun, magni-negative yung exponent ni y raised to n. That's why we will have y raised to negative n dy plus y raised to, or plus p times y raised to 1 minus n, kasi originally meron tayong y doon, and then nag-divide tayo ng y raised to n. So by laws of exponent, ang magiging exponent niya is 1 minus n dx, and of course doon sa right side, q dx na lang siya, na-cancel na yung y over n. And actually, ang Bernoulli's equation will fall under differential equations na gagamit ka ng substitution that is suggested by the equation. And anong substitution yon? Kung mapapansin natin kasi, meron tayong y raised to n dito. At kapag dinerive natin yon, actually, makukuha natin is 1 minus n times, bawasan mo ng isa yung exponent ng y, magiging 1 minus n minus 1 is negative n, and then dy. So, nandito siya. Yung derivative niya, yung parts nung derivative ng y raised to negative n, sum of its terms ay nandito. Wala nga lang siyang 1 minus n, which is okay lang naman because n is just a constant term or a number not equal to 1. So, sa madaling sabi, pwede tayong gumamit ng substitution sa Bernoulli's equation. Yan. If we let z equals y raised to 1 minus n, and then we derive dz equals, syempre, power rule yan, yung 1 minus n na exponent ni y, bababa. And then, power rule sa differentiation is, or sa derivative, bawasan natin ng isa yung power. Kaya naging y raised to negative n na lang siya. And as you can see, nasabi ko nga kanina, itong part na ito ay nandito sa ating equation, sa pangatlong equation natin. And then ito, mapapalitan na ng z. So, pwede na tayong mag-substitute. So, yung y raised to n dy, since wala siyang y 1 minus n para maging dz, so yung y raised to n dy ay magiging dz all over 1 minus n. And then, itong y raised to 1 minus n na katabi ni p is yun yung nilet nating z, kaya naging z siya. And then, of course, dx. Sa kabila, yung q dx, wala ka namang isa-substitute dyan kasi wala na siyang y. Remember na nag-divide na tayo doon para mawala yung y doon. And then, since ito rin yung one restriction or one reason kung bakit nilet natin si n not equal to 1, because if sinama natin na n is not equal to 1, syempre 1 minus 1 dito, we are dividing by 0, which is, of course, hindi pwede. Kaya that is also one reason kung bakit we consider n or all values except 1. And since number itong si 1 minus n or that n is a constant number, pwede nating i-multiply siya sa lahat para lang matanggal siya sa denominator, and we will end up with dz times 1 minus n dz dx equals 1 minus n q dx. So, from the general or standard form, sabi na natin standard form ng Bernoulli's equation, nagkaroon tayo ng ganito by using a substitution na ito, z equals y raised to 1 minus n and dz equals 1 minus n times y raised to negative n dy. And what happened when we substituted these values? Kung mapapansin natin, anong itsurang ito? Kamukha na siya ng first order linear differential equation. Diba, kung matatanda niyo yung first order linear differential equation, y prime plus p of x, y equals q of x. Or kapag ginawa natin siyang in terms of dy dx, dy plus p of x, y dx equals q of x dx. This is linear in y. Meron kang isang dy, dalawang dx. Yung isang dx, meron siyang katabing y at function ni x. And then doon sa right side, yung isang dx may katabing function lang ni x, wala siyang y. And this is very similar or parehas na parehas yan dito sa last equation natin, which is linear in z. Meron tayong dz, meron tayong dalawang dx, meron tayong z dito na ang katabi niya is function ni x or yung p function ni x, and then yung katabi naman ng dx dun sa kabila is a function din ni x, which is q. Remember, n dito is a constant number lang. So, sa madaling sabi, yung Bernoulli's equation natin will end up being a first-order linear differential equation if we let this substitution. If we let z equals y raised to 1 minus n. But of course, kapag isosolve na natin siya, kailangan nating ibalik yung z. And syempre, dahil first order linear differential equation na ito, alam na natin, supposed to be, kung paano kunin yung solution nito, which is yung ginawa nating mnemonics. I think that is SPIMIS, ata yun. gawin mong standard equation, hanapin mo si p of x, and then hanapin mo yung integrating factor, multiply the integrating factor dito, integrate, and then simplify. Diba? SPIMIS. Pero pagdating, dahil linear in z ito, or dz dx to, pag nasolve mo na, hindi pa dun magtatapos. Kasi kailangan mo munang i-substitute back yung nilet mo na z equals y raised to 1 minus n, and yung mga dc niya, or z lang, kung merong may matitirang z doon. So, basically, ganun lang siya. So, para lang siyang pinahabang first order linear differential equation. Nagkaroon tayo ng substitution muna. So, it's up to you kung gusto mong i-follow itong ganitong process ng pag-derive, or kung diretso ka na dito, wala namang masama kasi galing naman siya sa standard equation. Um, Make sure nyo lang na dapat naka-standardize or naka-standard equation yung hinahanap nyong equation muna bago nyo i-apply kung dito na kayo kaagad. But I do not encourage you to do that kasi of course kapag may bago or may binago sa problem or mayroong certain part sa problem na hindi na pasok dito, 'di ba? Mahirapan tayong mag-adjust kung nandito na tayo kaagad. That's why I derived it for you for this video. So let's try to solve an example para mas maintindihan. So meron tayong equation dito na y times 6y squared minus 6x minus 1 dx plus 2x dy equals 0. Siyempre, yung standard equation natin is, doon na ako sa part ng dy. We have dy plus, ano na yun? Py dx equals q y raised to n dx, if I remember correctly. Yes. Where p and q are functions ni x. So, basically, dahan-dahanin na lang natin, i-distribute natin muna lahat, and then we regroup lahat ng may dx and dy para mas malinaw. So first, I will distribute y, 6y squared minus xy minus y dx plus 2x dy equals 0. Then I will distribute dx. So, sorry, x 6y cubed na ito. Xy minus y. Okay. So 6y cubed dx minus xy dx minus y dx plus 2x dy equals 0. So based dito sa standard equation natin, mauuna si dx ay yung may dy. So ang may dy lang dito is yung 2x dy. So ilagay natin si 2x dy dito. And then, yung may y raised to n, nakatabi, yung dx, nasa right side siya. Ito, sa qy raised to n. And obviously, yun yung 6y cubed dx. Tapos, dapat ang matira lang na may dx dito sa left side is yung may katabing y. Ayan, which is ito. Kapag finactor out natin, sa part na ito, finactor out natin yung y, we will have y, negative y times x plus 1 dx. Ilipat natin sa kabila si 6y cubed dx, magiging negative 6y cubed dx. So, hindi pa siya kamukha ng standard equation natin kasi dapat walang kasama si dy doon. Magde-divide tayo ng 2x sa lahat para magkaroon tayo ng dy minus, so i-separate ko lang yung mga functions ni x dito para mas makita natin kung ano yung p at ano yung q. So we have negative 6. Negative 6 all over 2 is negative 3. Negative 3 all over x, y cube dx. Ayan. Meron na tayong dy plus py dx equals qy raised to n. Kamukha niya na. where ang n natin is, of course, equal to 3. So, kung nakaganito na yung equation nyo, pwede nyo nang actually indirekto dito. But keeping in mind yung mga substitution na ginawa natin. So, pwede na kayo dito sa part na ito. dz plus 1 minus n pz dx equals 1 minus n q dx. Or, kung ayaw nyo, pwede rin namang from scratch. Total, nandito na din tayo. So, sa part na ito, ilagyan ko ng arrow for continuation. Or hatiin ko na lang siya. Ayan, dito. We let z equals y raised to, ano yung lagyan natin? Y raised to 1 minus n. So, 1 minus 3, that is y raised to negative 2. So, ang dz natin is equal to negative 2 y raised to negative 3. That means we will have, meron tayong dy dito. Okay, hindi pa pala tayo nag-divide ng y raised to negative, y raised to 3. So, pag nag-divide tayo ng y raised to 3 all over, remember dito, dapat wala nang katabi si q na y raised to n. So, pag nag-divide tayo ng y raised to 3, meron tayong y raised to negative 3 dy minus x plus 1 over 2x y raised to negative 4, or sorry, 1 minus 3 is negative 2 dx, which is equal to negative 3 all over x dx. At yun, pwede na natin gamitin tong mga substitutions na ito, which is c equals y raised to negative 2 and dc is negative 2 y raised to negative 3. And so, yung y raised to negative 3 dy dito sa ibaba, mapapalitan na natin yan ng dz all over negative 2 via this substitution or assumptions minus x plus 1 all over 2x. Y raised to negative 2 is z. So z dx equals negative 3 all over x dx. And we will end up having linear in z. Pero kailangan muna natin palang ulit mag-multiply ng negative 2 para mawala yung nasa denominator niya. So, we will have dz. Pag minultiply natin ng negative 2 itong part na ito, meron siyang 2 sa ibaba, tapos may negative sign sa ng harapan. So, positive na siya. And then, mawawala na yung 2 sa ilalim. Then, dito naman, magiging positive 6 over x dx na siya. So, linear in z na ito. Wherein, ang p natin is yung katabi, yung may dx na katabi ni z, which is, ang p natin is x plus 1 all over x, or that is 1 plus 1 all over x. So, we will look for the integrating factor. The integrating factor is e integral of p dx, which is e integral of 1 plus 1 all over x dx. So, this part is sa may part na ng first order linear differential equation. So, kapag nakalimutan nyo na, you have to review. Which is equal to, pwede nating i-distribute integral ng 1 all over x dx will give us e raised to x plus ln of x. But, rules of exponent, separate natin si e raised to x at saka e raised to ln of x. because itong e raised to ln of x will simplify to x. And therefore, ang integrating factor natin, if, is equal to x e raised to x. Ito yung imumultiply natin dito sa part na ito. So, next slide na ako. Yung equation natin is dz plus x plus 1 over x z dx equals 6 all over x dx. If I got it right, yes. At ang integrating factor natin is x e raised to x. So, i-multiply natin ng x e raised to x both sides of the equations. And by doing so, dahil first order linear differential equation ito, syempre yung first part or yung left side ay magiging exact differential. Derivative na ng product. Product ng alin? Nung z, kasi linear in z tayo, times yung integrating factor na x e raised to x. And then yung right side, kailangan natin siyang i-simplify. So, 6 over x dx yon, tapos multiply natin ng x e raised to x. May makakancel yung x. Ang matitira lang is 6, sorry, 6e raised to x dx, which is a function of x. Kaya madali lang integrate. So, integrate natin. Syempre, nagtabi ang integral at derivative. Makakancel lang yun. Z x e raised to x equals 6. Factor out natin kasi constant term siya. At ang integral ng e raised to x is e raised to x pa rin. And then, syempre, huwag natin kalimutan yung plus c. At dito, hindi pa tayo tapos kasi originally, yung equation natin is in terms of y and x. So, dapat palitan natin or i-substitute back natin yung value ng z. Yung z natin, nilet natin dito as y raised to negative 2. So, palitan na natin siya ng y raised to negative 2 x e raised to x equals 6 e raised to x plus c. Okay, so we can do some algebraic manipulations dito or simplifications. Mag-divide tayo ng first e raised to x siguro. So pag nag-divide tayo ng e raised to x, we will have y raised to negative 2 times x equals 6 plus c e raised to negative x. So from ibaba, itinaas ko siya. And then, i-separate na lang natin siguro yung y raised to negative 2 and x. Yung y raised to negative 2, pwede natin siyang i-rewrite as x. Sige, ilagay natin sa baba. X all over y raised to negative positive 2 na pag binaba natin. And then equals 6 plus c e raised to negative x. Then i-cross multiply lang natin yung y squared. Or actually dito, nag-multiply na lang sana tayo ng y raised to negative 2. Pero syempre mas sanay tayo sa mga cross multiplication. Ganyan. Whatever works for you. So x equals 6, y squared plus 6 c e raised to negative x. And that is our final answer. So, ganun lang naman siya. Medyo para lang siyang pinahabang first order linear differential equation kasi hindi pa obvious na magiging first order linear differential equation siya kapag hindi natin in-apply yung proper substitution as suggested by the equation. So that's it for Bernoulli's equation. Thank you.